Now we're looking at Egyptian division. We're gonna have two examples here. First example, we try to divide 91 by 7. So 7 is what we call divisor, and 91 is what we call dividend. So instead of doing long division, we're going to try to see how Egyptians divide these two numbers. The idea of Egyptian division is kind of similar to multiplication. So we're going to start with the divisor 7. 1, write down 1 7. And the idea is to try to get how many 7s equals 91. So we're trying to use the method of doubling to try to come up with 91. So we're going to do 2 7s. It's going to be 14. And next we're going to do 4 7s, which would, or you can just simply doubling 2 14s. You will get 4 corresponds to 28. And we can try to do one more time. So we're doubling both numbers to get 8 and 56. If we do it one more time, we will get 16 over on the left column and 112 on the right side. But we are trying to reach 91, and 112 is bigger than 91, so there's no point to do that. So we can stop right here and see if it's possible to come up with how many, to come up with on the right column with 91. So we check those numbers pretty much by trial and error and figure out if we can come up with 91. In this case, we're lucky. 7 plus 28 plus 56, that gives us exactly 91. And we check the left corresponding numbers. So we can see 1 7 plus 4 7s plus 8 7s will add up to 91. So which tells us we add them to get 13. So that means 13 7s equals 91. And that means 91 divided by 7 equals 13. So this will be our answer. But what if we cannot, with the numbers on the right column, we cannot come up with 91? So what we should do in that case? Okay, so if we divide, look at another example. We divide 35 by 8. By looking at them, we know that 8 is not going to 35 exactly a certain number of times. So we cannot get exact the whole numbers. How many 8s equals 35? So let's see how we're going to do this. So the idea is still similar. We try to double 8, keep doubling 8, and see if we can get close to 35. So we double both sides, and we doubling it again, we get 32. And if we double it again, we get 8 on the left column and 64 on the right column, which is bigger than 35. So we should be able to stop right here. But by looking at these three numbers, 8 plus 16, that's 24, and 8 plus 32, that's 40, and so there's no way we can come up with a 35. So what we're going to do is we are going to, instead of keep doubling it, we are going to try halving of 8. So we look at the first row. We're going to do 1/2 of 8, which is 4. And if we look at those numbers, it doesn't look like we're going to get exactly 35. So we're going to try to take half of 4, which is 1/4 of 8. So let's take half of 4. Half of a half is 1/4. Half of 4 is 2. So now we take a look at these numbers again, and it seems like we're still not going to be able to come up with the 35. So let's do it one more time. So we take half of 1/4, we get 1/8. Take half of 2, we get a 1. Because we want to get 35, and the 35 apparently is an odd number, so if we only have even numbers, there's no way you can come up with a 35. So that's why we have to keep doing this until we get a 1, which is an odd number. So now let's try to pick some numbers and try to make 35. So by checking these numbers, we found out 32 plus 2 plus 1, that's exactly 35. So we pick the corresponding column number, first column numbers. So we get 4 plus 1/4 plus 1/8, kind of similar to the 13 we got. So this is our final answer, which tells us this is the quotient. That's equal to 4 plus 1/4 plus 1/8. So this many 35s will give us, this many 8s will give us a 35. And from this method, you can see not only Egyptians were able to do multiplication, doubling it, but also finding the fraction of a certain integer.